All right, so thanks everyone. It's very nice to see you. I wish I could be there physically as well, but this works as well. So I'm Wenjun from Yale. I will talk about metamorphic surfaces and NextG networks. So I know this term is very long, but it's a play on meta material as well. Oops, sorry. Okay. All right, so there's been a lot of talks about what 6G is going to be, right? Because of course, that's where we're looking at next. Now, I'm going to offer a slightly different perspective. So as you can see, one of the key, if you look at the sort of service perspective or usage perspective, what's going to happen is that there's going to be more and more devices all serving human. So essentially, it's not just about the base station scheduling devices, but it's more like how devices are going to collaboratively serve the human user. Okay, so now what this also means is that we're going to have all sorts of devices, and then most of them will be connected wirelessly. So you're going to get wireless signal all over the place. And actually, one thing you might notice that, so here, these icons, they look like they have wings, they're actually wireless signals. But of course, one possibility is that we might even have flying kind of IoTs in the future as well. I'll get back to that later on as well. So with all these signals, now traditionally, we are used to thinking about managing all these wireless links and all of that, right? So you have the base station or the AP, you're going to schedule different users, and then you have to sort of, all these links share active spectrum. But then over time, as all these signals, there's more and more signals around, it's going to be increasingly difficult to manage all this propagation behavior at one point. And that's just the laws of physics, right? So in recent years, there's been some idea about making use something called smart surfaces here. So this is just one example. So, something like this. Essentially, you can think of it as a massive antenna array somewhere else. Whether that's going to be connected to the AP or base station or something else, that's a separate issue. It's more system level design. So the idea is that once you have this kind of massive array somewhere else to help the whole radio environment or the system, then potentially, because of the large degree of freedom of having all these antennas, they might actually do a better job of organizing or focusing the energy, steer the energy propagation in the whole environment. So something like this, for example, where instead of individual devices sort of having signals going kind of randomly, you can actually control them better. So I've been working on this for a while. Now, there are a few, so here I'm only showing the hardware, but actually, so the stuff on the left-hand side are actually end-to-end systems. So there's actually, they are disconnected they're separate from the AP or the clients. And then we have a way to sort of control this hardware to see how do they actually adapt to in real time to active link behavior and also propagation behavior, so that they can do something to improve the perceived channel quality at the receiver. So I know it's kind of hard to see what's happening here, but this is essentially just an antenna array with phase shifters. And then this is actually a metasurface array, a metasurface design, which can do polarization, rotation. And then this is what you see here, some of these little things with LED. So these are actually LED lights, but what they are connected to are little sort of devices which can amplify signals and then essentially route signal over the space, so you can actually have more control over where the signal is going. So some of this work actually collaboration with other folks, and anyway. Now, and then this is actually very recent work we are sort of experimenting. This is why I'd call this metamorphic surfaces. So we're actually trying to do something a bit more different. Now, so why are we talking about metamorphic surfaces? So if you look at all these prototypes, right, and then there are actually a few more prototypes here. So all of these, they can essentially, the idea is almost like you can overlay the wall or some kind of hard surface with antenna array. And sure, you can do some, you can sort of try to do things as experiments. But then, practically speaking, there's actually a lot of limitations to what you can do in terms of deployment and also efficiency, right? So if you look at something more schematically, these kind of surfaces actually work better when it's closer to an end device because of laws of physics. So because you need to be able to focus beam or collect energy more efficiently, and it's just more physics says it's more efficient near either the transmit or the receiver. But also, if you think of this as part of the wireless infrastructure, especially as an extension of the last mile and etc., then in the end, or whether it's in a home or office or even outdoors, actually outdoors is even harder. There's actually not many places you can place large number of very large size rigid surfaces. So this is of course a little cartoonish kind of example, but the idea is that you cannot, if the device is actually in the middle of the room, the nearest place will be the couch, but you cannot do something similar as what we did before, right? But of course, we also know from the very basic antenna propagation or early design, if you have a very flat array, it's just not as efficient as, say, a circular array or some other different design in terms of focusing energy and light. So that, again, makes the whole practical deployment and also the whole design a lot more complicated. So that's why we actually have been experimenting with trying to instrument something different. So initially, I called it soft surface, but again, the term can mean a lot of different things. So for example, we tried curtains, and for a bunch of different reasons. One is it's, of course, not hard and rigid, right? But also, curtain is also another place where it could be an indoor-outdoor interface. So that could, you could imagine. So for example, I often refer to the curtain behind me when I talk with my students, especially over the past year and a half. So for example, I often notice that where I'm sitting, I don't get very good cellular reception. So I really wish that the curtain behind me could actually act as a cellular repeater so that my, when I talk on the phone, my reception can be actually improved. Now, it doesn't, so these prototypes don't do that, but that's actually how we started doing these kind of things, right? And then what's also interesting here is that they actually combine with the natural use of the object. So for example, as the curtain, so in this case, the curtain is actually hung off at a mechanically motorized track. So there's actually a way to move the curtain automatically. And then as they move along, they change the shape anyway. So we're also trying to see how can we make use that to improve either using beamforming or and the like. And then the blinds example actually, oops, sorry, I meant to more interesting because you can rotate the blinds. And again, of course, that has a natural functionality of letting or block the sunlight. But also, as you rotate, they also adjust the amount of energy that's actually directing in different directions, and that can be combined with how you want the same energy propagation to go between the endpoint. So that's actually where we got to for this part. And then what's interesting, of course, is this is interesting idea. It's actually still in very early stages. I mean, you see the hardware right now. That part is actually not a complete end-to-end system. So of course, there are a lot more challenges and also opportunities, right? So typically, as far as complete the whole system, there are, so there are a lot of challenges. So there are common challenges that you need to actually know what's happening around you in order for the surface to do something sensible. So the addressing channel information and that is actually the typical. But then in this case, once we start to change the shape and all of that, then you actually start to deal with all this shape management and try to how to actually change the shape and all of that. These are actually new challenges. So the question really is, because essentially there's no models for these kind of situations. So can we actually use machine learning or AI or essentially some kind of data-driven approaches, right? Of course, there are also new opportunities because essentially I was trying to make use of this example using these flying drones. And so we're basically making some kind of cloak or, cloak with connectivity support. So can that be used for other kind of everyday objects, clothing and the like, right? And then of course, in fact, one of the ideas also this connects really with soft robotics. So robotics fabric, for example, and it could be an example of say, system or infrastructure for AI connecting with robotic applications. That's all I have. Thank you.